Good morning, friends and students. So, I am Dr. P. Prabhu, Associate Professor, Department of Civil Engineering, Konganadu College of Engineering and Technology, Tiruchirappalli. So, today we are going to see in this video the water supply and wastewater engineering laboratory experiments, based on which the first experiment is yet to be start with determination of pH and turbidity. So, let's start with the experimental part. Okay, good morning, friends and students. Today we are going to see about the laboratory experiment pH and turbidity. So here we are going to use the instrumental method. So hence this is a pH meter for identifying the pH from the water, and already we have been prepared a solution of pH 4 and pH 9.2 solution in this 2 bottle. So these are all the apparatus required for this pH meter, and this is an electro rod that shows the measurement of pH in water, and this is a pH meter. And next in the experiment we are going to see the turbidity water. So this is a turbidity sample we have with us, and this is a pure sample we have with us. So based on which we are going to identify the turbidity in the water, prescribed water, and also the calibration in the turbidity meter. And this is the turbidity meter, and which shows a digital format of the answers. And here turbidity is being measured by NTU, that is naphthalene turbidity unit, and pH has got no any measurement. So let's start with the pH. So this is the sample we have to identify the pH. So before starting the experiment with the pH meter to identify the pH, let us calibrate the pH solution with 4 pH and 9.2 pH solution. So we can wash our electrode knob and wipe with the tissue paper, and let us calibrate the instrument with pH 4 solution. So you can see there is a drastic reduction of pH. So it will be around 4.2. It will be drastically down to it, and again we can wash it and wipe it with the distilled water, and again you can calibrate with 9.2 pH solution. So you can see that drastically it gets off, increases to 9.2. Again we can wash with the distilled water, right? So this is the calibration method. So this shows that the machine has got calibrated with pH 4 and pH 9.2. Once we shown with the pH 4, the calibration should reach us to 4.2, and when we are calibrating with 9.2 pH tablet, and it has to be drastically increased to 9.2. So repeat this once or twice so that the calibration is get off over. So now our calibration is got off over. Okay, and we have a sample for that, right? So this is a groundwater sample. So let us wash my electrode knob with tissue paper and the distilled water, and just you can insert the knob. You can insert the knob in water so that the pH gets off measures. So let us wait for some time. When the reading is getting off stopped or with standardizedly which start up, okay, we can measure the reading. So we can wait for some few minutes. Yes, so it is 7.78. okay, around. So again you can wash it and wipe it, the electrode knob. So always this electrode knob should be in acid water or in the salt water. So again just I am dipping it to getting some concurrent value, right? So you can see the measurement again. So it is getting off down, and around we are getting 9.4, 9.5, so 7.8, 9 or something. So whatever whatever the reading you are getting from here, and we can note it down as the result of pH. So it is around 7.7. Okay, and we can again wash through. And that's all about the experiment of pH. So first, let us have a calibration with pH water of 4 and 9.2. So once you repeat once or twice with that, so your machine has got us calibrated with the 4.2 and 9.2 pH, and then you can wash with the distilled water, and we can have a sample, and the sample can be tested directly through the knob, and you can measure your pH. Right. Okay, students, and let us see the next experiment is turbidity. So hence you can see this is the turbidity meter, and this is a pure water, and this is the turbidity water. And with the continuity of pH, and now let us see the turbidity in the water. We have two kind of in a sample with us. One is in a blank sample, and one is the turbidity sample with us. So in the last case we have seen the pH. So the pH in the water should be around 6.5 to 8.5 for the drinking purpose. This is as per 10,800 code. Okay, so you can check your pH based on which the purpose can be acceptable for drinking or not can be identified based on code 10,500 code. And now you can see the turbidity, and we have a two sample of the with mean turbidity, as I said. One is with the turbidity water and a normal water. So first we can take this turbidity knob. Let us pour pure water, that is distilled water, with this. Right. So let us have a scene. There is a mark in the knob. Okay. So we have to pour the water till the knob touches, and there should not be any bubbles in the knob. And let us have this blank sample into the turbidity meter. So let us watch the reading. You see the turbidity shows around 0. If it does not show 0 or minus 0 or something else, we can make 0 based on this calibration. So this is the first step to identify, to do the calibration for an turbidity meter. So first you can make a calibration with a sample water. So I have made it with a sample water, and just I am keeping it again. Let us watch, and it belongs to 0. The reading is 0. So hence there is no any turbidity in the water. You can easily able to identify. So this is the calibration. You can do once or twice this calibration, and next you can take your turbidity sample, or the sample what we have to identify this. So let me take some sample, and I am pouring into it. So let us see. So it should not be, and bubbles may not be. So let us make some shaking here so that the bubbles will relieve. So automatically this mark has been till the mark the water has been uploaded. So just I am keeping my sample in the inner of turbidity. So let us watch. The turbidity is around. So the turbidity is getting measured. So you can see, so around 9.8, and it is getting drastically a little bit reduction. Yeah. So now turbidity is around 7.9 it shows, and you can note the reading 7.9. So what is the reading which has been stopped from there? You can note it, the reading of turbidity in NTU. So the turbidity in the drinking water should be less than 5 NTU, that is naphthalene turbidity unit. So most probably there should not be any turbidity in the drinking water, but as per the code we have a less content of, as per the code it should be less of 5 NTU. So this is about the turbidity. So let us make a calibration with a small sample, okay, with a blank sample, and after the calibration of setting of 0 of the instrument, you can have the sample what we have with you, and that can be inserted to it and identify the NTU, that is turbidity unit of NTU the turbidity of the water can be identified. So now let's see what is our turbidity in the water. So you can see the instrument. So it is around 4.5 NTU. Okay, 4.5 NTU. Right. So okay, thank you friends. And today we have seen about the two experiments. One is pH and also the turbidity. And the pH should be limited up to 6.5 to 8.5 as per Codal drinking water standard Codal 10,500, and the turbidity should be less than 5 NTU. So this is as per standard code. So as per IS 456, the water should have 6.5 to 9 pH for the purpose of construction while we are using for PCC or RCC or whatever the construction purpose you are using it. So this is as per IS 456, right? And the turbidity should be also very less while using for the construction purpose. This is as per IS 456 2000. And based on your results, you can identify the purpose of the water can be used for drinking or construction can be identified based on this, both the experiments and both the codes. And thank you once again, and we will watch you in the next experimental video.